Please, wait a bit while we prepare the mission environment. This training mission follows the procedures described on the flight manual of the real aircraft, adapted for use on the A4E Community Aircraft Module of DCS. The procedure step numbers, when provided, corresponds to those of the NATOPS manual. For brevity, we will skip those steps that corresponds to items not simulated yet, or that can't be performed on DCS. Even though the interior inspection is not really needed, as on DCS it is assumed already done. This training mission you can choose to perform the interior inspection anyway, to provide cockpit familiarization to new pilots of the A4E. If you are short on time, you can choose to skip all checks and tests that are non-essential on DCS. The cold start procedure includes the following sections. Interior inspection. Before starting the engine. Starting the engine. Post-start checklist. If the cockpit interior is too dark, activate the flashlight with right Control plus L. If the yellow cross cursor is not visible, press left Alt plus left Shift plus C to make it appear. You can adjust the sound volume produced by the background air traffic, by moving the in-cockpit sound slider, on the DCS options, audio screen, which you can access by pressing the escape key. This instructor's volume level can be adjusted with the helmet sound slider. Also, you can press spacebar to skip long voiceovers. Press backspace if you want to perform the interior inspection section of the cold start procedure. If you prefer to skip this section, press spacebar. Skipping the interior inspection section of the cold start procedure. Press backspace if you want to perform the check steps of the cold start procedure. If you prefer to skip those tests, press spacebar. You have chosen to perform all the functional checks of the cold start. Starting the engine. The A4E electrical system does not include batteries. Also, there is no APU to provide starting air. Because of this, an external electrical power supply and a source of starter air are required for ground starting the engine. 1. External ground power. Connect. Bring up the communications menu, with the / key. Select F8. Ground crew. F2. Ground electric power. F1. Turn power on. Even though we asked just for ground electric power, the ground crew is also connected starting air to provide airflow to rotate the turbine during the ignition.
Ground power is now on.
2. Master press to test. Check. Press and hold the master test button to check all the warning lights. APC. ECM. Angle of attack indexer. Wheels. Labs. Laws. IFF. Fire. RBST. Pilot and armament advisories. Radar altimeter on. Oil low light. The fuel quantity and liquid oxygen quantity indicators will rotate counterclockwise. The liquid oxygen warning light will come on when its needle passes through 1 liter. 3. Throttle off. Check that both the virtual aircraft throttle and your real HOTAS throttle are at the off position. 4. Engine starter switch. Depress to start. When the switch is depressed, the starter air supply valve opens, allowing compressed air to rotate the starter. A holding relay retains the switch in the start position. Once the engine speed reaches approximately 50% RPM, the engine starter switch will pop up, stopping the air supply to the starter. 5. At 5% RPM throttle to ignition, by right-clicking the throttle lever. The ignition switch is actuated by movement of the throttle inboard, from the off position, into the ignition position. 6. At 15% RPM. Throttle to idle, right-click again. This opens a fuel cutoff valve in the fuel control unit, providing fuel flow to the engine and allowing it to start. 7. Stabilized idle RPM. 56 to 58% at 20 degrees Celsius. Light off should occur within 20 seconds after the throttle is moved outboard to start the ignition cycle, and is indicated by a rise in EGT after the throttle is moved to the idle position. Normally, the engine will stabilize at idle RPM within 45 seconds from depressing the engine start button. 9. External electrical power and starting air. Disconnect. Now that our aircraft's engine is running, electrical power is being supplied by a 10 kV engine connection, so we can now disconnect the external ground power. Bring up the have the ground
Copy.
crew disconnect from the aircraft both the electric and air supply connections.
Ground power is now
If
on.
flight off is satisfactory and engine speed is stabilized with the throttle at idle, check the following. 1. RPM. Idle at 56 to 58% at 20 degrees Celsius. 2. Exhaust gas temperature. Between 200 to 340 degrees Celsius. 3. Fuel boost, light out, on advisories panel. 4. Oil pressure, 35 to 50 psi. 5. Oil quantity indicator, light out. Electronic equipment warm-up. The A4E electronic equipment needs a warm-up time before we are able to do their pre-flight checks. We will turn them to standby, so they can warm up while we do other checks. A. Turn the navigation computer to standby for a 2 minutes warm-up. B. Turn the Doppler navigation radar to standby for a 5-minute warm-up. C. ARS-63 ICLS system. It does not require warm-up, as it is solid state, but we can perform its bit test as follows. C1. Set the 3-position MCL power switch to on, with a left click. 2 red warning flags should appear on the ADI at the 12 and 3 o'clock positions. The vertical director pointer indicates full right and the horizontal director pointer indicates full up, both being almost out of sight. C2. To check the system, hold the switch in the bit position, with a left click and hold. C3. Correct functioning of the system is indicated if on the ADI the vertical pointer oscillates between 1/3 scale right and 1/3 scale left at a 4-second per cycle rate, and if the horizontal pointer is centered. When released from the bit position, the switch will return to the on position, and the test is terminated. Post-start checklist. When electrical power becomes available after starting engine, check the following items. 2. UHF function switch. Set to DR+G. The Skyhawk is equipped with only a single communications radio, an ARC-51A UHF radio, which provides voice communication between aircraft, ships, or ground-based radio stations. This radio is energized by rotating its function selector switch from off to DR or TR+G. It can tune frequencies between 225 and 339.95 MHz. 4. TACAN switch, set to receive for a 3 minutes warm-up, then set to transmit receive. 5. AFCS set to standby. The automatic flight control system is the Skyhawk's autopilot system. It will maintain heading, altitude and pitch and bank angles, and is also able to perform a coordinated turn to a pre-selected heading automatically. Placing the switch to standby provides electrical power to the AFCS for warm-up. The system should be in standby at least 90 seconds prior to engaging the stability augmentation switch, or the AFCS main engage switch. Nine. Fuel quantity. Check internal and external readings. The fuel quantity gauge indicates the total fuel available, in thousands of pounds. The range of indication is from 0 to 6,400 pounds. The highlighted toggle switch is used for checking external fuel load. The external fuel amount will be indicated when the switch is held to the EXD position, with a left click and hold. 10. Check oxygen quantity. Take note. Oxygen is supplied by a vacuum bottle liquid oxygen converter mounted in the aft fuselage section. The bottle contains 10 liters of liquid oxygen when full. It should be noted that although 100% oxygen is used at all times, duration is greater at high altitudes. 10 liters lasts 60 hours at 40,000 feet, down to 7 hours at sea level. 12. Standby ADI, erect, off flag not visible. Adjust by left click and hold, and then turn the mouse wheel. 13. Compass controller panel. Set. Not simulated yet, but the panel elements are animated. On the real aircraft, You have to choose between free or slaved operation, the latter being preferable as it uses a flux valve to keep the gyro oriented to the magnetic north. (14) Rain removal system. Check for flow, then off. System not simulated, but the switch is animated. 15. AFCS run checks, then ensure off after checks completed. The AFCS checks are performed using the AFCS test panel, on the right console. The three indicators R, Y, and P, represent the control current to the AFCS servos for roll, yaw, and pitch respectively. The 1 and 2 switch allows two test conditions. The switch is spring-loaded in the normal position and when performing tests must be held in either test position 1, with a left click and hold, or test position 2, with a right click and hold. The AFCS mandatory check consists of 4 tests, performed with the AFCS engage switch enabled and while holding the 1 and 2 switch at test 2. Begin by lifting the 1 and 2 cover, by clicking on it. To begin the check, hold the 1 and 2 switch at test 2, with a right click and hold. Keep the switch pressed during the whole check procedure. Now, engage the AFCS. As we have the mouse busy, use the A key instead. 1. Aileron limit switch check. Move the flight stick to the right. At about half deflection, the autopilot should disengage, and the engage switch will be seen to slip to its off position. Good. Now center the stick and re-engage the AFCS by pressing A. Now move the flight stick left. At about half deflection, the autopilot should disengage and the engage switch will go off. Correct. Now center the stick and re-engage the AFCS by pressing A. Good. Remember to keep the 1 and 2 switch holding at test 2. Now, move the trim hat to the right, with your HOTAS or the right control plus / keys. The autopilot should disengage, and the engage switch will flip to its off position. Good. Now center the trim hat by press and hold onto the left control plus D keys, and re-engage the AFCS by pressing A. Now move the trim hat to the left, with your HOTAS or the right control plus comma keys. The result should be the same as before. Next, center the trim hat by press and hold onto the left control plus D keys, and re-engage the AFCS by pressing A. (3) Trim monitor switch check. On this check, move the flight stick aft, and then move the trim hat toward nose up, with your HOTAS or the right control plus dot keys. The autopilot should disengage and the engage switch goes to off. Good. Now center the trim hat by press and hold onto the left control plus D keys, and re-engage the AFCS by pressing A. Now, move the flight stick forward and then move the trim hat toward nose down, with your HOTAS or the right control plus semicolon. The results should be the same as before. Good. Now center the trim hat by press and hold onto the left control plus D keys, and re-engage the AFCS by pressing A. 4. Autopilot check. To press the flight stick's AP override button, using the HOTAS or the left control plus A keys, the autopilot should disengage, and the engage switch will flip to its off position. 5. The pilot will know from the above tests that the AFCS has electrical power on all its servos and that the safety circuits are operating. Release the 1 and 2 switch. Now, close its cover, and turn the AFCS standby switch to off. Leave the switch at off for takeoff. Good. This finishes the AFCS mandatory check. Press spacebar to continue. Navigation computer check. The ASN41, is one of the earliest Doppler navigation computers, used in conjunction with the APN-153 Doppler navigation radar. It is a primitive unit that can handle only two waypoints, D1 and D2, plus the present aircraft position. 1. Turn the function selector knob to test. The computer will do a pre-solved navigation solution, and show it on the navigation displays and on the BDHI indicator. 2. Turn the BDHI switch to the nav computer position, with a right click, so that its pointers show data from the navigation computer instead of the TACAN. The test values should be: wind speed indicates 223 knots. Wind direction indicates 091 degrees. Latitude present position shows south integration. Longitude present position shows east integration. BDHI pointer 2, the one with double needle, indicates 30 degrees right. BDHI pointer 1, single needle, its indication depends on present position and destination. 3. Turn function selector switch knob to standby. 4. Turn function selector switch knob to D2. Using the slew knobs, input latitude and longitude for the D2 waypoint. For this training mission, let's set as D2 the coordinates of Rota International Airport. Its latitude is 14 degrees, 10 minutes north. Set the counter by left or right click on the outer ring of the knob, and hold the mouse button until the desired value is displayed on the visor. Good. In the same way, now enter its longitude. 145 degrees, 14 minutes east. 5. Now, turn function selector switch knob to D1. Same as before, enter latitude and longitude destination counters for the D1 waypoint. For this example, let's set D1 to Andersen Air Force Base. First, enter its latitude, 13 degrees, 35 minutes north. Good. In the same way, now enter its longitude. 144 degrees, 56 minutes east. On the real A4 you would now input, on the present position counters, the latitude and longitude of your current location. However, on DCS, these coordinates have already been entered, saving you this step. 7. The magnetic variation is the angular difference between the magnetic north and the true geographical north, and it varies according to the date and what is our current location on the surface of the Earth. On the DCS maps, the magnetic variation average values are: Caucasus, 6 degrees east. Nevada, 12 degrees east. Normandy, 8 degrees east. Persian Gulf, 1.6 degrees east. The Channel, 10 degrees east. Syria, 5.1 degrees east. For our current map of Marianas, the average magnetic variation is 0.9 degrees east. Input the value by left-clicking and hold, over the highlighted knob, while at the same time turning the mouse wheel. You may need to use both hands. Input wind direction and velocity. Since once in flight, the Doppler radar will feed calculated wind data to the navigation computer. This step is not needed. 9. Leave function selector knob in standby. Navigation radar check. 1. Turn selector switch knob to the test position. The memory light should illuminate. The ground speed dial should read 121 knots, while the drift angle dial should read 0 degrees. 2. Turn selector knob to standby. Prior to takeoff, turn selector knob to the on land or on sea position, depending upon the terrain to be flown over. 16. All flight controls. Free, full travel proper movement. Move the control stick left to right and front to back, checking that the control surfaces move accordingly. Move the rudder pedals left and right and confirm that the rudder moves accordingly. 17. Check flight devices operation. A. Flaps, full open. Check the extension looking at the gauge. Use the HOTAS or the F key. B. Speed brakes, open. Use the HOTAS or the B key. C. Hook, down. Extend by clicking the cockpit lever. You can also use your HOTAS or the left Alt plus G keys. D. Spoilers, up, then cycle with throttle. The spoilers are wing-top deployable surfaces used to reduce landing distance. They retract automatically when RPM is over 70%, to cater for a bolter trap. To perform this check, extend the spoilers with the engine at idle, then hold the wheel brakes and increase RPM to 70%. To check the automatic retraction, use the HOTAS or the S key. Retract flight devices. A. Flaps, set at half extension. Check the extension looking at the gauge. Use the HOTAS or the F key. B. Speed brakes, closed. Use the HOTAS or the B key. C. Hook, up. Click on the cockpit lever again, or use either your HOTAS or the left Alt plus G keys. D. Spoilers, down. Use the HOTAS or the S key. 19. Rudder trim, check and set at 0. Turn the knob while checking the left gauge. Horizontal stabilizer, set. Adjust using the trim head on the HOTAS, or the right control plus colon, or right control plus semicolon keys. For carrier takeoff, use 7.0 degrees of nose up. 22. Aileron, stick centered, check both left and right trim. Adjust using the trim head on the HOTAS. 24. Drop tank pressure, off. Placing the drop tank transfer switch in off de-energizes the drop tank air. 25. Emergency transfer, check. Emergency transfer of fuel from the wing tanks to the fuselage tank is possible. A wing fuel switch provides for the transfer of fuel by wing tank pressurization. Moving the switch to the EMER transposition closes the wing tank pressure and vent valves, allowing engine compressor bleed air to pressurize the wing tank. Fuel is then transferred to the fuselage tank through the pressure fueling line. Congratulations, this concludes the after-engine light-off section of the carrier cold start procedure. The aircraft is now ready to launch. You have successfully finished this training mission. On the next mission we will learn the carrier taxi and launch procedures. For now, please exit the training by pressing spacebar.